Welcome to the Crazy Hats Chemist. So here we go. Good morning, good afternoon, and good evening. We got another worksheet here to do, folks, in general chemistry, and it's called Atomic Structure General Chemistry Worksheet number 2. So let's see if we can hammer through this and see what you can do. So one of the things that you're going to need before you get started on this worksheet is a proper periodic table. This is the periodic table of elements in which I'll be using here. I'm going to zoom on out here just so that you can see it in its entirety. And so this is the one that I'll be using. You could probably use any periodic table, and then that would be perfectly fine for this little activity. But this is the one that I'll be using, and I highly recommend that you use one very similar to this. Okay, so without further ado, let's get started on this worksheet here. Let's zoom in on this and answer all these questions here. Shouldn't be too bad. Okay, so what we got here is the following. We're going to use the below notation answering the following questions. Right here, this notation is called standard nuclear notation. Okay, and in standard nuclear notation, it is written in this following fashion, and that's A, X, and a Z. And each of these components have a special meaning to them. The A is the atomic mass, which is the sum of the protons and the neutrons. Okay, perfect. It just so happens that the protons and the neutrons are the two subatomic particles that are located inside the nucleus, and that's why it's called the mass. X is the element symbol, and it can be either a capital letter or a capital plus lowercase. And then we can clearly see that on the periodic table here. So I'll just zoom into a section of the periodic table to answer that concept here. So, so the element symbol can either be a single capital letter, and I've just highlighted some of those, or alternatively, it can be a capital and a lowercase. All right, cool. Really simple there. You do not have two capital letters ever, and there is not a lowercase letter all by itself. Perfect. All right, so let's see if we can answer some more. Z is called the atomic number, which is equal to the number of protons. It's actually equal to the number of electrons, and that's the caveat is in a neutral element. So in a neutral atom. Okay, that's the caveat with that. All right, so just make sure that you understand that. All right, so in order to answer the rest of these questions, we're going to be taking example or the use of this standard nuclear notation, and also the concept that the mass is equal to the sum of the protons and the neutrons, and that the symbol is a single capital letter or a capital and a lowercase. And the atomic number is the number of protons. So since A is the sum of the protons and neutrons, and Z is just the protons, if I were to take the difference between the A and the Z, I would actually get the number of neutrons. Okay, I want to be taking advantage of that as well. All right, so what we're going to do is we're going to scroll this on up, and we're going to zoom in on this section here of this worksheet, and we're going to answer these questions on this here. Okay, perfect. Here we go. So this first one is phosphorus 32. So phosphorus 32. So this 32 is actually the atomic mass. So that is 32 right there. Now I need to look on my periodic table, and I need to find out where phosphorus is. So these numbers right here are called the average atomic masses of these elements here. Okay, and so I am looking within this region, since it's an average, and this is written down as phosphorus 32 as an isotope of an element. We'll talk about isotopes a little bit later, but this is an isotope of an element. Then that means that these averages, okay, won't necessarily exactly match this whole number of 32. So I need to look within this range. I did some before 32 and some after 32. And within this, I will actually find phosphorus. Now I will find the element symbol, which is a P. So that's the one letter designation in this particular case, and the atomic number, which is 15. So I'm going to take advantage of that atomic number 15 and the P for the symbolic notation. So it's a P, it's an atomic number of 15, and then there's 32 right there. And so what I'm doing is I'm following what I had up there before, which is the AXZ pattern. Okay, but I'm going to highlight some specific numbers here. So this 32 and this 32 is equal to the A, which is the atomic mass. That's the sum of the protons and the neutrons. And then this number 15 here is called the atomic number. That is the atomic number. So therefore, the atomic number is right there. And what is the atomic number equal to? It's actually equal to the number of protons. So the atomic number and the number of protons are exactly the same. Furthermore, if it's a neutral atom, and this is of course a neutral atom, then the number of protons is, the number of electrons is equal to the number of protons. So there's how we get that right there. All right, and then what we're going to do is we're going to do a simple subtraction problem. So we're going to take the difference between the mass and the atomic mass and the atomic number, and that will be the number 17 in this particular case, and that will give you the number of neutrons. All right, fantastic. We're going to do the next problem here. I'm going to highlight a few things, and then we'll just keep on moving. So this 63 is represented, the A is represented by a 63, and 63 is the atomic mass. This number, 29, is the atomic number. That's 29. The 29 atomic number is equal to the 29 protons. And since this is a neutral atom, this is 29 electrons as well. So I'm just going to highlight the same color coding sequence here. There's that Z, that's the atomic number, and the atomic number is equal to the number of protons. Then I have the A in my symbolic notation, and that's the 63, which is, of course, the atomic mass. Now, what we're going to do is we're going to find atomic number 29 on our periodic table. That is right here. And what element is that? Well, that is copper, and the symbol is Cu. That's capital C and a lowercase u. So that's a capital C and a lowercase u, just like it had here, and it was copper. Copper, and it's dash 63. So that mass number is repeating again, just like that. Okay, so hopefully you get that. I won't have to rewrite that highlighting section there again. And you should double check here. And one last thing that we need to do is we need to get the number of neutrons, so that we're going to subtract the atomic mass, that's the 63, and the atomic number, that's the 29. I'm going to get 34 neutrons. All right, perfect. Now what we're going to do is do the next problem. And this next one, we have the atomic mass. So that is actually 65 up here, and that's going to go at 65 after the dash. The atomic number is 29. That's the 29 protons, and that's a 29 here. And there are 29 electrons, since there are 29 protons. If I take the difference between 65 and 29, I'm going to get the number 36. That's the number of neutrons. I'm going to look on my periodic table for atomic number 29. And we just actually did this, but I'll do this just for giggles. And that is 29, and that is a Cu, and that's copper. So copper, and then a Cu right there like that. So you may be asking, well, this is copper 63 and this is copper 65. That's correct. What differs between these two are right here. They are the same element, but they have different numbers of neutrons. That is an isotope. It's the same element. That is the same number of protons. That's the same atomic number. However, different numbers of neutrons. Consequently, the mass is going to be different in addition to that. All right. Let's do the next problem. All right, so the next one here, I have the protons and the neutrons. So if I sum up these two numbers, that will be 18. That will be the atomic mass. Okay, the atomic number and the number of protons are equal. The atomic, so the number of protons and the number of electrons are equal. I have the atomic mass as 18. That's my A. The atomic number is an 8. That's my Z. And then I'm going to look up on my periodic table atomic number 8. That is O, and that is oxygen. So I'm going to write an O right there. That's a capital O, and it's oxygen, O-X-Y-G-E-N dash, and an 18. Perfect. Next one, next row, and that is I have 55 electrons and 66 neutrons. So if I were to say, well, since I have 55 electrons, I must have 55 protons since it's a neutral atom. And then that means that the atomic number is 55. If I were to add up the number of protons and the number of neutrons, that would equal 121. And that is going to be my mass. 121 is my mass, 121 is my mass, and it's atomic number 55. So I'm going to find number 55 on my periodic table, and that's right here. That's atomic number 55. That's CS, and that is for cesium. So that is a capital C, a lowercase s, C-E-S-I-U-M dash 121. Perfect. Okay, we're going to do the next problem here, and I have the protons and the neutrons. I need to sum up these two numbers here, and that's 113 and 74. That will equal 187 for the atomic mass. The the number of protons and the number of electrons are going to be the same. The number of protons and the atomic number are the same. And so I have 74 for the Z and 187 for the A. So I'm going to look up 74 on my periodic table, and that is right here, 74. That's W for tungsten. All right, so that's a W. And that's tungsten, Tungsten dash 187. Perfect. I've completed that section. Now what we're going to do is we're going to slide this up. I'm sorry that we're going to miss this top section here, but I believe that you are actually getting what we're doing. So I'm going to slide this up. So we're going to continue with this process here. So we got yep, there we go. So you have the pattern of which we've done before. This next one is uranium-238. That 238 is the mass of uranium. And so I'm going to look on my periodic table and I'm going to find elements that are close to 238. And there you should see uranium, and that's a U. Its atomic number 92. So that is a capital U. It's 238. Its atomic number 92. Its atomic number 92. The number of protons 92. It's a neutral atom, so 92 electrons. And I'm going to take 238 minus the 92. That is, I'm going to take away the atomic number from the atomic mass, and that will give me the number of neutrons, which is 146. Perfect. All right. Let's keep on going here. A little bit of selfless advertisement here. You are watching the Crazy Hat Chemist, folks. And that's right. Please subscribe to my YouTube channel if you find this stuff interesting and informative, and you are learning. So that's what's most important, that you are actually learning throughout this entire process. All right. This next one is atomic number 1. So that goes right here for atomic number 1. And the atomic mass is 2, right there like that. And since the atomic number is 1, the number of protons is 1. The number of protons is 1. The number of electrons is 1. If I take the difference between the atomic mass and the atomic number, I get 1. That's the number of neutrons. I'm going to look on my periodic table to find atomic number 1. Atomic number 1, that is H for hydrogen. All right, fantastic. So that is the H, and it's hydrogen, Hydrogen dash and a 2. This is called hydrogen 2, or actually the scientific name is deuterium, or heavy hydrogen. All right, So the next one is similar symbolic notation, and this is just very similar to what the copper examples that we had at the top of this worksheet. And we have hydrogen 2, and this one is going to be actually hydrogen 3. That is the mass. So hydrogen dash 3s, right? This is actually called tritium in its scientific name. No, so that's tritium, and this is the only isotope of the 3 isotopes of hydrogen of which is radioactive. All right, and atomic number 1 and the number of protons 1, number of electrons 1, and I'm going to take the difference between the atomic mass, that's 3, and the atomic number 1, and I'm going to get 2, which is equal to the number of neutrons. Fantastic. Next one is barium 140. So barium 140. So I'm going to look on my periodic table and I'm going to find masses closely approximating 140. And you should see that. And then there is barium, that's Ba, and that's element number 56, which is atomic number 56. Okay, so that is a B and an A. That is 140, and that's atomic number 56. So that means that the mass is 140, the atomic number is 56, the number of protons, 56, the number of electrons, 56. I'm going to take the difference between the 140, which is the atomic mass, and the 56, the atomic number, and I'm going to get 84, and that is the number of neutrons in this isotope of barium. All right, the next one has an atomic mass of 90. That's going to go there. That's going to go here with a dash right before that. And then atomic number of 38. So that's 38 protons and 38 electrons. And 38 is the atomic number. So if I were to take the difference between 90 and 38 right here, I'm going to get 52, and that's the number of neutrons. I'm going to look on my periodic table and find the element number 38. Number 38 is right there. That's Sr for strontium. Strontium. So that's S and an R. That's a capital S, a lowercase r, STRONTIUM-90, strontium 90. That's probably a radioactive isotope. Okay, so next one. Protons is 60, neutrons is 87. So if I sum up these two numbers, 60 and 87, then I'm going to get the number, the atomic mass, which is 147. Since the number of protons is 60, the atomic number is 60. Since the number of protons is 60, the number of electrons is 60. And then the atomic mass is 147. The atomic number is 60. I'm going to look on my periodic table and find element number 60. And that is right here, neodymium. So that is a capital N, a lowercase d, NEO, DYMIUM dash 147. All right, fantastic. So let me zoom on out so that you have this entire worksheet here so that you can see the entirety of this worksheet. And let's see if we can do that here. Almost perfect. And there we go. We are almost there. There we go. I think we can manage to fit that right in there. Perfect. So you should see this entire worksheet right here. I've used a periodic table. It's crucial that you use this periodic table to do this entire worksheet right here. And that should be it, folks. All right. I will see you next time for more crazy videos, and have a great day and see you next time. Thank you very much. Bye now.